Torricelli theorem. Scientist Torricelli derived this one, and this theorem, the final equation or mathematical equation, is solved using the Bernoulli's principle. Now first, what is the Torricelli's theorem? We know that any object is dropped, the dropped object is called by freely falling body. The dropped object is called by which one? Freely falling body. The freely falling body touches to the ground. We know its velocity or final velocity v is equal to root 2gh. How we can get this equation? From the third equation of motion. The freely falling body initial velocity is 0. That's why we take the third equation of motion. V square minus u square is u is 0. V square is equal to g, height is h. So this is the equation of the freely falling body. The same we can derive here. Now this is one container or one tank, water storage tank. Here tap is provided. Okay, the water is comes out from this, or liquid is comes out from this. The liquid is comes out with some velocity, but the which is come out from this narrow hole or orifice. Orifice means small hole or narrow hole is called orifice. From the orifice or from the narrow hole, the liquid is comes out. This liquid is called by water or oil, whatever it may be. This liquid is called efflux liquid. What it is called? Efflux liquid. If this liquid is ejected from this orifice, it has some velocity. That velocity is called as a which one? Efflux velocity. This is one water storage tank or oil storage barrel. It has one small hole or narrow hole. The narrow hole is called orifice. From the orifice or narrow hole, the liquid is comes out. Which liquid is comes out? Technically it is called efflux liquid. This efflux liquid has some velocity. That velocity is called efflux velocity. This efflux velocity is equal to, okay, now from the orifice the efflux liquid is ejected now, but up to here the liquid is there. The liquid is up to here. Now from this orifice the liquid is comes out. When the liquid is comes out, it has some velocity. Whatever the efflux velocity, that is equal to, let us take one object. If we can drop that, from here you take one object, drop them, that moves freely towards the ground, and whatever the velocity it is achieved here, the freely falling body velocity is gradually increases. Whatever the velocity of freely falling body to reach up to here means at h height from the surface is equal to the efflux velocity. Are you followed? The efflux fluid velocity is equal to the from surface to the orifice. You can drop one object which is at h height. Now whatever the velocity of freely falling body to reach from this to this or this height, whatever the velocity of freely falling body at this point, this velocity is equal to efflux liquid velocity. This is called Torricelli's theorem. This is the explanation. Okay. Now we write the statement. The velocity of efflux or efflux liquid as you wish. The velocity of efflux or efflux liquid, that is velocity with which the liquid flow out of an orifice. Velocity of efflux or efflux liquid. What it is called? The velocity with which liquid flow out from an orifice. What is the meaning of orifice? A narrow hole is equal to whatever the velocity is here, whatever the velocity of the liquid from this orifice is equal to that which a freely falling body would acquire an falling through vertical distance equal to the depth of orifice. What is this one? Depth of the orifice below the free surface of the liquid. This is the free surface of the liquid. This is the depth, or we can say height. Up to height the freely falling body reaches, whatever that velocity is equal to the efflux velocity. This is the statement. What is Torricelli's theorem? Now we want to prove that. From Torricelli's theorem, you take any drum or water storage tank or oil storage barrel. When it has small hole here and liquid is up to here, from surface of liquid to orifice, some depth is there, some height is there. From the surface to the depth, the freely falling body moves, it is achieved some velocity. Whatever the velocity is gained by the freely falling body from the free surface to the orifice is equal to the efflux velocity of the fluid. This is the statement. Now how we can prove that? We can prove, or it is verified by using Bernoulli's theorem applied at point A and B. What is the A? Free surface of the liquid or a water, and B is the height of the orifice. What is the Bernoulli's theorem? P1 plus half rho V1 square plus rho GH1 is equal to P2 plus half rho V2 square plus rho GH2. We know the Bernoulli's principle. What is that one? P1 plus half rho V1 square plus rho GH1 is equal to P2 plus half rho V2 square rho GH2. Now let us take ATA. ATA means the free surface. P1 is equal to P means atmospheric pressure. It is not flows at point A, so velocity is 0. Now from orifice, how much height is there? H. At B, we know that one, the liquid is in rest. The pressure at all points is same as per Pascal's law. As per Pascal's law, pressure is same at all points. At all points when the liquid is in rest. So P2 is equal to P. Velocity, okay. The liquid is comes out from the orifice. That velocity is V. What about the height? This is the height, but here there is no height. With a reference to this only we can take height. That's why H2 is equal to 0. Substitute that. P1 P, V1 0, H1 H, P2 P, V2 is V, H2 is 0, P plus this is 0, rho G H1, P plus half rho V square, this is 0, rho cancel, rho G H is equal to half rho V square, so GH is equal to V square by 2, so V square is equal to 2GH and V is equal to rho to 2GH. Next, we can write another one, rate of flow. Rate of flow. Rate of flow of fluid, or what we can say, that is volume flux. What is the volume flux? V by dt is equal to A into V. Okay, so that is A into root 2GH. Okay, this is another equation. Okay, this is what is A? Area of the orifice. What is A? Area of orifice. A is equal to pi r square. So AV is equal to pi r square into 2GH. This is about the Torricelli's theorem. Venturi meter. This meter is designed by scientist Venturi. What is the use of this instrument? This instrument is used to measure the flow of speed of the fluid. We find the speed of the fluid flows through the narrow pipe from huge diameter of the pipe to narrow pipe. That's why this Venturi meter is used in the perfumes and also in carburetor of the vehicles. In perfume, we can press it from small hole, we can get the scent spray. Which meter is there? Venturi meter. Now let us see. With the help of Venturi meter, in science what we can find? The speed of the fluid or the flow of speed of the fluid. The Venturi meter is a device to measure the flow of speed of the fluid. This device works under Bernoulli's principle. It has, this is one tube. It has one tube. Here diameter is more, but here the diameter is small, means small constriction at middle. Here diameter is more, here diameter is more, but here it is constriction, just like throttling, pressing at this place. It is pressed. Okay, here area is more, here area is more. In middle between, middle of this one. Actually, we want to extend the diagram. No need. No need. That's why we can write. See that one, parallel. Here also parallel. But here what happened? It is constriction. Small constriction is there. Okay. Now, this Venturi meter consisting of a tube with a broad diameter and a small constriction at the middle. Here diameter is broad, here diameter also broad, but here what happened? Small constriction at middle. Between them, from constriction place to the broader diameter, this is point 1, this is point 2. In between them, what we can connect? Manometer. Manometer is in which shape? U shape. Which liquid is taken in that one? Maximum mercury. Maximum what we can take? Mercury. Why? The high density of the liquid is mercury. Maximum in manometer which is used? Mercury. So the manometer is U shape. This is the mercury, the shaded lines. Okay. Which measures? What is the use of this one? Mercury is measures the pressure difference. Now the liquid is flows here. Area is more, so the pressure is less, but area is less, the pressure is more. The difference of the pressure measured by which one? Manometer. Here area is more, pressure is less. Here area is less, pressure is more. The difference of the pressure is measured by which one? Manometer. Okay. Now use the which one? Bernoulli's principle. What is the Bernoulli's principle? P1 plus half rho V1 square plus rho G H1 is equal P2 plus half rho V2 square plus rho G H2. Venturi meter means consisting of which one? The broad diameter of the tube, but the constriction is that. That's why it is a horizontal pipe. That's why I am taken horizontal line. It is a horizontal pipe. So H1 is equal to H2. Then what happened? P1 plus half rho V1 square is equal to P2 plus half rho V2 square. Take in this side P1 minus P2 is equal to half rho V2 square minus V1 square, means P2 in this side, half rho V1 square in this side. P1 minus P2, what is the difference in pressure? The difference in the pressure is rho G H. But I am taken rho dash. What is the rho dash? Density of the mercury. What is rho dash? Density of the mercury. Here we want to write it. Rho dash. Rho dash is density of mercury. What is rho density of flow of fluid. Okay, right. Okay, 2 in this side, 2 rho dash. P1 minus P2 is rho GH, but what is the rho here? The mercury rho dash GH is equal like this, and you take this here. So what we can get? V2 square minus V1 square is equal to 2 rho dash GH by rho. Let us take equation 1. From that one you take V1 in this side plus remove the square, we can get answer. From equation 1 you take V1 square is common, V2 square minus V1 square minus 1. You take V1 square is common, here we get this formula. We know that equation of continuity. A1 V1 is equal to A2 V2. Take square on both sides. A1 square V1 square is equal to A2 square V2 square. So A1 square by A2 square is equal to V2 square by V1 square. You substitute this value in equation 1. Okay, substitute this in equation 1. ఇక్కడ రాస్తే అయిపోతుంది కదా. Substitute it in equation, what we can take? 2. You take it, this is 2. Okay, this is equation 1, this is equation 2. We can get the answer like this. Okay, this is the way to calculate the which one? The velocity of the fluid. Especially Venturi meter is used, especially in the perfumes. Perfumes means scent perfumes, otherwise in automobiles as a carburetor. Okay, this is the use of the Venturi meter.